Logging is very important for IT companies as it helps debugging production issues and identifying when they started. However, it can become very expensive, costing millions. Today, I will show you how we have built Optikon, our own internal logging tool, what has saved us most of our cost. Hi, I'm Rafael Borrego, IT manager at Readum.com, an e-commerce company. Here you have my blog. Readum is a big company. We have more than 1,000 employees around the world accessing the logs, and we generate more than 8 terabytes of logs every single day. In Readum, we used to have a lot of monitoring solutions, and there were multiple company acquisitions. These tools were managed by multiple teams, so there was a lot of duplicated effort that we wanted to centralize in a single team. It was difficult to manage cost. Each of these tools works in a different way and had a different payment model. Some of them we pay by millions of logs, in other we pay by tickets, in other we pay by terabytes of logs. So it's not always easy to see where the application costing us most of the money. It was difficult to manage logs across all the different applications, as every time that one person moves across teams, we had to give them access to different tools and different permissions. Also, some of the logs were not accessible. Every time there was a production issue, someone had to log into a host and use basic tool like grep in order to find logs, what we wanted to have in a single UI. Also, there was a high learning curve. Every time that someone moved across teams, they had to learn a new tool. So they were not ideal, and we wanted to simplify that. And we decided to choose a single vendor and move all of our logs into it. However, it didn't work as expected. The good thing is that we had a single UI, so every time that something failed, we know where to go. And also we have all the permissions centralized. However, we have problem with cost. Every time that we added logs to this application, we had to pay a lot more money. And there was a moment in which we were scared about more people using the tool. We had duplicated cost, as some people started to use the new tool, but in parallel, they were still using the old tool. So we were paying twice for the same. There was no cost awareness. So people thought that sending log was almost free, and they sent anything, without being aware of the massive impact on cost. Also, sometimes they enabled by accident verbose logs, and we had to pay a lot for it. Also, one of the challenges of these tools is that we had to pay the same for every log. However, not all the logs are equally important. For example, the logs for a development environment are not as important as the log for production, and a verbose log is not as important as a error log. So, shall we pay the same for them? Probably not. Also, team didn't have time or budget to modify all the applications to comply with the new tooling. Why? Well, every application logs in a different way. They use different logging libraries, different metadata, so we need to do something about that. Also, for some applications, we didn't have any kind of experts, and they had led the company. And it was difficult to change how people were using logs, and they have been doing the same for many years, and it was hard to improve. So we use this as a way to learn, and we discovered that although we wanted to do things in a way, reality was very different, and it was better to adapt to reality. We evaluated different tools, and also all of them had similar issues, so we decided to build our own solution, what we call Optikon. What are its features? The first one is that we have a single UI, so every time that there is an issue, we know where to go. And also, all the permissions are centralized. It has cost guardrails, so in case that one application gets out of control, we are going to be notified and we are going to apply rate limiting or throttling. Data regulation laws are very important, and it is fully compliant with the laws in California and GDPR in Europe. One of the main advantages is that I did not need to change any application code. Any kind of transformation, we do it in the gesture layer or in the log agents. For us, reliability is very important. So in case that one region goes down, it's not a problem because we have multi-region. We have very good alerting integration with PagerDuty, Slack, and email. So in case that we identify certain errors, we are going to be contacted immediately. And it is very affordable. We are saving up to 95% of the cost. In terms of usability, we have multiple infrastructure across Europe, the United States and Asia. And we wanted to have a single dashboard where we can see everything. Also, we wanted to correlate data in logs, metric, and traces, as usually when there is an issue, we can see the impact on all of them. And we have some applications that are very complex and composed by multiple services. So we want to see when there is an error, how that error propagates across the different layers. And this is what it looks like. On the top left, you can see some metric like the number of logs ingested per minute and on the type of the logs. You can also see examples of the logs, and we can click and expand. On the top, we also have very good search capabilities, and we have a tool that allows users to learn how to write queries. On the bottom, we also have metric and traces, something that we will cover another day. So this is its feature and what it looks like. Today, I will show you how we have built it. So here you have two sides. On the left side, you can see the application, and on the right side, you can see the ingestion pipeline. On the application side, we have different sources. We have application running Kubernetes, an application running virtual machines, and we have a log collection agent. We have chosen Vector as it has very good support for multiple technologies. On the right, the first layer is an HTTP ingestion layer. The good thing about using a standard HTTP is that it decouples the business applications from the logging tooling. So in case that we want to change the tooling in the future, we won't have to modify any business application, saving a lot of time and effort. This first layer also does authentication. For us, it's very important to know which application is sending each line of log, so we can later apply different transformation, or we can apply rate limiting. So we generate one application key per application. The next component is a log aggregator. For this, we have also used Vector. Here we do multiple things. One of them is routing. Depending on the log type and the application, we store it in a different place. We can also do a log conversion. For example, we can transform metadata, or we can add new metadata fields that might be missing. And we also have guardrails. So in case one application gets out of control, we can do different things. We can apply rate limiting, we can do throttling, or we can change how that application stores logs. Then on the right, you have the log storage layer. We have two approaches. The first one is to use OpenSearch. I ensure that you know Elasticsearch from the ELK stack, and OpenSearch is the managed service. We have two flavors for it. One is the standard OpenSearch, and the other one is ultra warm. The difference is that ultra warm is slower, but a lot more affordable. So what we do is that for the first few hours, we store the logs in the basic on the standard OpenSearch, and after a few hours, we move it to ultra warm to save cost. Then we take all the logs and we store them in S3. Why S3? Because it is very affordable and we don't have to worry about cost. It can be a bit slow, but the way that we make it faster is that we use a tool called Loki that indexes all the logs and allows to query them very, very fast. What is the difference between S3 and OpenSearch? In OpenSearch, we store the most important logs, the error ones and the warning ones, and sometimes the info ones, whereas in S3, we store everything. Also, we use S3 for DR, so in case that there is an outage and OpenSearch goes down, we can rehydrate logs in another region from the logs in S3. Apart from this, we have Prometheus to store log-based metrics. One of the advantages of Vector is that at the same time that it does routing, it also allows to generate different type of metrics and to store them in Prometheus, so we can later access them. And then, once that the log have been ingested, we have a single frontend for everything. One of the standard frontend for Elasticsearch will be Kibana, but we have preferred to use Grafana because it has better integration with multiple sources. So from Grafana, we can get logs from OpenSearch, we can get logs from S3 through Loki. Another advantage is that we can connect directly to CloudWatch. We have multiple serverless applications generating logs into CloudWatch, for example, Lambdas. And one of the good things is that from Grafana, we can query that directly. So we don't need to store those logs anywhere else, saving a lot of money. From Grafana, we can also query Prometheus to see different metrics. And we also have a very good integration with PagerDuty. So we can send alerts to Slack, email, and any other way. Then, in terms of how we built it, one of the main things was consistency. We wanted to have very similar settings across all the different environments, and also we wanted to be able to rebuild the environments whenever we want to. For this, we have used Terraform and other tooling like Spacelift. There are multiple ways to deploy the components. One thing that we like a lot is Kubernetes because it allows to manage different things like auto-scaling. And it can also allow you to move to multi-platform in the future. However, every time that we can, we have used AWS managed services to reduce the setup and maintenance effort. You will see that for Grafana, we have deployed it also in Kubernetes, although there is an AWS managed service. And it is because this version on AWS is not good enough for us. For example, it doesn't support all the alerts that we need. Another thing that we wanted was to use multi-region everywhere to ensure that in case of outage, we are covered. And we need a tool to monitor the monitoring tool. So we have used CloudWatch for that. This is all for today. In case you want to know more, you can look at our website. Soon we are going to add a blog where you can read more. And also you can see more about what we do and our open positions in case you want to work with us. Thank you.